Hey everyone, and welcome. Have you ever looked at a big, complex idea and just wondered, how on earth do you turn that into cold, hard data? Well, today we're pulling back the curtain on the blueprint researchers use to do just that. We're diving into quantitative research, where big questions get transformed into measurable, testable facts. Let's get into it. So, this is the big question, right? How do you do it? Well, it's not magic, not by a long shot. It's actually a super systematic journey. It's all about taking something kind of fuzzy, like, say, job satisfaction, and creating a really precise, structured plan to actually measure it. And in this explainer, we're going to walk through that exact process, step by step. Okay, so our journey starts right here, in the world of big ideas. Every great study kicks off with a theory, a framework that tries to explain how different things in the world are connected. But here's the catch. A theory is way too broad to test all at once. So the very first job for any researcher is to start breaking it down into smaller, more manageable, and, most importantly, measurable pieces. And yeah, this slide lays it out perfectly. Think of it like a funnel. You start way up at the top with a broad theory. From there, you pull out the key concepts. These are the essential building blocks. But you can't just measure a concept, right? So you need indicators to act as stand-ins, like specific questions on a survey. And finally, at the very bottom, you create precise measures that let you capture all the little differences. See? It's a clear path from this abstract idea all the way down to concrete numbers. And this brings us to the absolute core building block of all quantitative research, the variable. A variable is just a fancy word for anything you can observe or measure that can, well, vary. It could be someone's age, their income, the temperature outside, or even their opinion on a scale from 1 to 10. And as we're about to see, really understanding the different types of variables is crucial for doing good research. Right, so not all variables are created equal, and this is super important. On the left, you've got variables where the numbers mean something real, something with a consistent scale, like time or temperature. A room at 20 degrees Celsius is truly twice as hot as a room at 10 degrees. But then on the right, you have variables where the numbers are basically just codes or labels. Think about your rank in a race, first, second, third. You can't say that first place is twice as good as second. Understanding this difference is going to be absolutely critical when you decide how to analyze your data later on. Okay, so we've broken down our big theory and we've figured out our variables. What's next? Well, now it's time to make a prediction. This is the moment we go from just describing stuff to actually testing a relationship between things. We've got to put together the one core question that's going to drive this entire study. And that prediction, we call it a hypothesis. Now, a hypothesis isn't just a random guess. It's a formal, testable statement. And the most important part is that it has to be falsifiable. That means there has to be a way to actually prove it wrong. For example, you can't test the hypothesis that unicorns are pretty, right? There's no way to disprove it. A good hypothesis creates a direct link between our theory and the variables we're about to measure. And this right here is basically the central drama of every research study. You've got these two competing ideas. On one side, you have the null hypothesis, or H0. This is the skeptical default position. It assumes nothing interesting is going on, for instance, that there's no salary difference between two groups. On the other side is the alternative hypothesis, H1. This is what the researcher actually thinks is true, that there is a salary gap. The whole point of the research is to gather enough evidence to see if we can confidently reject that skeptical null hypothesis and say, nope, something's really going on here. Now, before we get all excited and rush out to collect our data, we have to hit the pause button. We have to ask a really critical question. Are our measurement tools any good? This is the quality control stage. Think about it. If your tools are flawed, any data you collect is basically garbage. It doesn't matter how brilliant your hypothesis is. And this all boils down to two huge pillars, validity and reliability. Here's an easy way to think about it. Imagine you step on a bathroom scale and it says you're 7 feet tall. That scale is not valid. It's supposed to measure weight, not height. Now, what if you step on it 3 times in a row and get 3 wildly different weights? Well, then it's not reliable. It's not consistent. For a study to be any good, you absolutely need both. You have to be measuring the right thing, and you have to be measuring it consistently. And researchers have a whole toolkit to make sure this is the case. For example, they look at something called face validity, like just on the surface, does this question look like it's measuring what it's supposed to? Or something more powerful is predictive validity. Can our measurement actually predict something in the future? For instance, does a high score on a job aptitude test actually predict who's going to be an amazing employee a year from now? These kinds of checks make sure the whole study is built on a rock-solid foundation. But here's where things get really fascinating. What a researcher even considers to be valid can depend on their fundamental beliefs about the world. A researcher who believes in a single objective reality might ask if their measure perfectly captures that reality. But another researcher, one who believes reality is socially constructed, might ask if they've included enough different viewpoints. So this just goes to show you that even in a world of hard numbers, there isn't always one single universal definition of truth. All right, our hypothesis is sharp, our measurement tools are solid. So now, who are we actually going to study? Obviously, we can't ask everyone on the planet, so we need a smart strategy for picking a group. This is the science of sampling. And there are really two main ways to go about this. Probability sampling is the gold standard if your goal is to have your results represent a much larger population. It's like a lottery. Everyone has a known chance of getting picked. Now, non-probability sampling is different. Its goal is much more targeted. You might choose specific people for a very specific reason, or just because they're easy to find. The key thing to remember is this. Only probability sampling lets you confidently generalize your findings to a bigger group. And of course, size matters. The sample size, which you'll often see written as a little n, is just the number of people in your study. And generally speaking, a bigger sample size, along with a good response rate, gives you a lot more confidence that your results aren't just some random fluke. So we have our validated tools, and we know who we're going to study. We've reached the final step in our blueprint, actually going out and getting the data. And one of the most common ways to do this is with a questionnaire. This is really where all that hard work we've done so far finally comes together. At its heart, a questionnaire is just a list of very carefully structured questions designed to get reliable answers from people. And it's incredibly versatile, right? It could be an online survey, a phone interview, or even a face-to-face chat. But whatever the format, the goal is always the same: to collect clean, consistent data. So what separates a good questionnaire from a bad one? Honestly, it's all in the design. The questions have to be crystal clear, with no room for confusion. The flow needs to feel logical. It can't be so long that people just give up. And maybe most importantly, it has to be pilot tested. You've got to do a test run on a small group first, just to find and fix all the kinks before you launch the real study. And this quote just nails it, doesn't it? Every single step we've just talked about, from coming up with a theory, to defining variables, to building a hypothesis, to sampling, to designing that questionnaire, it's all about one thing: preserving the integrity of the data. It's all about making sure that the numbers you end up with are a trustworthy reflection of reality. So there you have it, the blueprint for turning a big idea into solid, credible evidence. We've just walked through the toolkit that researchers use every day to explore the world in a systematic way. So the only question left is, now that you know how it's done, what would you want to find out? What question would you investigate?